So I want to give you 12.1 and 2. And the idea of these guys is just a new way to solve little systems of equations. You guys remember what a system of equation is?
No.
No? Okay, let me give you an easy example of a system then. 2x plus 3y is 7, and 2x plus 6y is 10. You guys remember these? Maybe? Algebra 1? No?
Yeah.
Do you remember a technique that we called the
Substitution or elimination?
Yeah, there's a substitution method and an elimination method. You guys remember those?
Yeah.
Oh, you find one by writing it.
Yeah, you kind of find one of the variables by getting rid of a different one, maybe?
Yeah, I remember.
Yeah.
You have to get like either x or y completely by itself, and then plug it back into the other x or y in the equation.
Yeah, so so depending on how you get there, that's either elimination or substitution or some little combo thereof. I just want to remember how to do that. So can you guys give me a hint for how to do this? What would I do?
Start solving one, and then when you get all of it to one side or one variable, you plug it back into that variable.
Okay, let me not do substitution, but that's how substitution would work. How does elimination work?
You multiply the top number by a negative so that the x's will cancel.
Yeah, you guys see that? So we might think about, okay, there's 2x up here and a 2x here, right? If I subtracted this equation from that one,
Oh, then you solve for y.
then I'd have y's by themselves, right? So to go from here to the next step, I'm going to say subtract equation 1 from equation 2, right? And I might think about subtract equation 1 as, okay, that's minus 1 times this jazz, right? So what's minus this jazz? Okay, negative 7 and
Negative 2x minus 3y.
negative 2x minus 3y equals negative 7, right? You guys see that? I'm just kind of writing it off to the side because I'm going to want to add that to this stuff. So in my next stage, I'm going to leave the first one alone. Right, 2x plus 3y is 7. And the second equation is going to become this thing plus that thing.
So 3y
So I'm going to get
equals 3.
So I'm going to get 0x plus 3y equals 3. You guys see that? Maybe not. Maybe if I wrote my minus equation 1 right here. Right? And then I'm thinking about, okay, take this, add it, put the result right here. You guys see that? Okay, and then what do I do? Okay, and then I divide equation 2 by 3. So I'll get y as 1. And the first equation's just still going to be 2x plus 3y equals 7, right? You guys see that? And now at this point I'll know what y is, and then I could plug it back in, right?
Yep.
You guys see that? Or I could subtract 3 times equation 2 from equation 1. You guys see that? If I multiply the second guy by 3, right, I'd have 3y equals 3. And then I could subtract that from equation 1. That'd get rid of the 3y.
Oh.
Right, so I'd get, let's see, my second equation is going to remain y is 1. And my first equation is going to be 2x is 4, I think. Right? And then I divide equation 1
If you were supposed to subtract
by
two,
2.
negative two.
So I'm supposed to subtract this from that.
Oh, okay.
Just plug in the y
I
value.
got the.
Yeah, we could just plug in the y value. The reason I'm doing it this kind of awkward way. You guys see that this last couple of steps has been kind of awkward.
Yeah.
The reason I'm doing it the awkward way is I want to teach you a new thing, and the new thing uses the awkward way. It seems less awkward when we do it in the new way. So then we'll divide equation 1 by 2, and I'll get, oops, not 2, but x is 2, right? And y is 1. And then I might want to remember why I would do this. What does this mean?
If you have a point in the graph, you can graph it.
Yeah, there's a point on the graph.
Yeah. And you
Of
want them
what?
to be able to
Equals 7.
Yeah, that's when if I plug it into both of these guys, I'd get 7 out of the first one and 10 out of the second one. What does that mean? What's this thing as a picture? What? Yeah, with some confidence, this first thing,
A
2x
line.
plus 3y is 7. That's a line.
Yeah.
2x plus 6y is 10. Also a line, but probably a different one. So I've got this kind of graphic of there's a line and a different line, and they hit somewhere. And maybe I should erase my axes since I'm not
This is
being
where we did
honest.
like the shaded line.
And this point where they hit is 2, 1. You guys all see that? That's really kind of graphically what this means. So I had 2 lines, they hit together
Where did
at this point.
Yeah.
You want to see the new thing?
Sure.
So all the new thing is a way to do this without writing x and y down constantly. Because while that's easy for 2 variables, if I had like 6 variables, that would be super duper annoying. Right? But it's easy for 2. So if I was going to write this down, I'm just going to write the equation down in a box without the variables. So for this first coordinate, you're going to think about x's. The second coordinate, you're going to think about y. And this third thing, you're going to think about the numbers. So in my first equation over there, 2x plus 3y is 7. How many x's are there?
2,
2. So you put a 2 in the x slot.
3,
How many y's are there? 3. So you put a 3 in the y slot. What's the number?
7.
7. So you put a 7 in the number slot. Then how about the second equation?
2 x's,
2,
6,
6,
10.
10.
Okay.
And then what's your goal? Your goal is to find out what x is and what y is, right? So in the x column, you want a 1. And in the y in that same row, you want a 0. You guys see that? My goal is to fiddle this around until I get to 1, 0, 0, 1 with a number and another number. You guys see if I could get there, I would have sort of x equals number and y equals number.
Yeah.
Oh, yeah, okay. It's kind of like, never mind. There's like a game where you do like a ton of numbers. It's like 6 boxes.
Oh, like Sudoku?
There you go.
Yeah, it sort of is like Sudoku. You're going to kind of fiddle with this until you can get the numbers to match the pattern that you need. Okay? So this is the pattern I want. How can I get these numbers to match it?
So you minus the 3
Let's see.
column, or like get a 0 in that column.
Yeah, let's see. So
So like get negative 1 and then like.
I'd like to get this to be a 0, right? You guys see that?
Oh. The bottom.
Yeah, you start from the bottom left on these.
Okay.
So I'd like this one to be a 0. So how do I get that to be a 0 with these 2 rows? Keep in mind the rows represent equations, right?
Right.
So over here, what did I do?
Minus the 2.
I took the top equation and subtracted it from the bottom equation, right? So over here, I'm going to do that same thing. I'm just going to write down underneath this the opposite of the first row. minus 2, minus 3, minus 7. You guys see that? And then I'm going to add that to this bottom row. You guys see that's the exact same thing I did over here? Over here I wrote down the opposite of the top row in blue, and then I added it to the second row. I wrote the top equation down again, and I got a new second equation. I'm going to do that same thing. I'm going to leave the first row alone, my 2, 3, 7. And I'm going to make a new second row by taking the opposite of the first row and adding it to the second. So what do I get here? I get a 0, 3, 3. What?
So what's your second step with that?
What's my second step here?
You need a 0 on the top still, right?
Yeah, I need a 0 up here, right? So I write down the opposite of the bottom.
Oh, the original number, or?
I can get a 0 there right now, right?
Okay.
So I may as well do that. So I've got, if I write down the opposite of the bottom, that's minus 3, 0, right? And now I want to add that to the top row. So I'm going to leave the bottom row alone. And the top row is going to become
0, 2, 0, 4.
2, 0, 4. Perfect. You guys see that?
And then you have x equals 2.
So I have 2x is 4 and 3y is 3 right now. So I'd like to divide it by 2 here and 3 there. You can do that. These represent equations, right? So we're going to do 1, 0, 2, and 0, 1, 1.
So you're dividing by what?
So I took, on this step, I took R1 and divided by 2, and I took R2 and divided by 3. See that? And up here, I subtracted R1 from R2. You guys see that? That was my first step I did. My second step from here to here was subtract row 2 from row 1. You guys see this? And at the end here, I've got, when I look at this thing, x is 2 and y is 1. You guys buy into the idea that this was at least a little bit different?
It seems like you just have like a lot of freedom to do whatever you want. You kind of just like, oh, I can.
Yeah, so what you can do, the things you're allowed to do, are you're allowed to multiply rows by stuff and add them to each other. That's really what you're allowed to do.
Yeah.
You guys see that's actually all we did?
Wait, what can we only do?
We can multiply rows by numbers and add them to each other. And that's really all we did, right? When we subtracted R1 from R2, we multiplied row 1 by -1 and added it to row 2. When we subtracted row 2 from row 1, we did exactly the same thing, but with the other row. When we did row 1 divided by 2, that's multiplying all of row 1 by 2, by 1/2, right? When we did row 2 over 3, that was multiplying all of row 2 by 1/3. That's all you're allowed to do, and it's all you need. See this? You don't like it? Okay. So for two equations with 2 variables, I would not recommend flipping to augmented matrix and solving. This is harder.
So just keep going from here to there to here to there. Down.
Yeah. And all we're doing is the same step. So if I thought about, all right, I started with this guy, and I got to this guy. Please note, if you read the just numbers off of this, you got 2, 3, 7, 0, 3, 3.
Yeah.
Right? That's exactly the same as the thing you have at the middle stage over there. Then here, I divided both things by 3, and I have basically the same content as someplace over there. You guys see that? This really is just a different way to represent the same amount of steps.
Yeah.
Okay.
So the way you did these steps is sort of a formula.
Yeah.
So 1 from 2, 2 from 1, and then divide.
Yeah, and of course I got a little bit lucky, right? Because this 2 matched that 2. If this had been
It
a
does
5 and that had been a 7, I would have had a little bit harder time. But we know a common multiple between 5 and 7. We could kind of multiply this row by 7 and this one by 5 and get a common thing, right? That would take a while, but that's really what we would do. Cool. The other thing that's nice about these is your calculator doesn't have a way to plug this stuff into it, but it does have a way to plug these things into it. Matrix. There's actually a whole matrix button on your calculator, which is to do with these guys.
Oh, I see it. And
Yeah, so you can just plug these in and hit solve,
Oh.
which is actually really, really nice. So the primary thing I want to teach you is how to convert between a system and a matrix. Because if you can convert to a matrix, you can plug it in a calculator. The other virtue of this is it works for bigger things. The substitution elimination method that we teach you in Algebra 1 is pretty well limited to use with maybe 3 equations and 3 unknowns. It doesn't do a great job past that. It gets really, really hard to keep track of all the variables. So I'm going to throw up some examples. Do you guys want to spend a second and try to rework them as systems?
Yeah.